Alright guys, welcome to Math 0314. We're on section 5.4, complex fractions. So, complex fractions are essentially when you have fractions and fractions, and there's essentially two ways to approach these sorts of problems. The first way is to realize that when we divide, so we have 5x squared over y, when you divide, this giant line right here just means division. We know that division is multiplying by the reciprocal. The reciprocal is just a fancy word for flipping the top and the bottom. So once I do this, all I have to do is tackle this right here, and we know that 5 goes into 10 two times, x goes into x squared once, and so we're just left with x, and then the same thing is true for y and y squared. So the result would be xy over 2. So one method is to take the division, realize it means multiplying by the reciprocal, so you take the bottom and you switch these position-wise, and then you just multiply. And from there, you should be at a point right now in the course that to go from here to here is second nature to you. Now there's another way to do this, and that requires a little bit more ingenuity, and you think a little bit more. And this move, you want to get rid of y squared and y. And the easiest way to get rid of these is to multiply by y squared. And the question that perhaps is emerging in your mind is why? Well, if we do this y and this y squared will cancel and it'll leave me with y. So in the numerator, I'll now have 5x squared y. And the denominators, they cancel out, and we're left with just 10x. And from here, we can divide 5 into 10. We'll have 2 on the bottom. X goes into x squared, and you're x, and you're left with the answer, which is xy over 2. Notice that in both methods, we get the same result. Now, I can tell you from my experience in teaching this course that most people like this first method over the second method. But you can't really have an opinion yet on it without practicing it a couple times. So with that being said, let's look at the next question and let's tackle it. But before I let you tackle it alone, we want to note how this is different. And what we see clearly is that we have on the top and the bottom, the numerator and the denominator, we have fractions inside of fractions. And we're subtracting fractions. So the first move, irrespective of what method you use, is to get a common denominator. So that means I got to multiply this side here by 2x over 2x, and hopefully that's apparent because this will give me 4x. And on this one, that's 3 over 1, I'm going to multiply top and bottom by 2x, so we have a common denominator of 2x. What this is going to leave me with is 1 minus 6x over 4x all over 6x minus 1 over 2x. Okay. And once we get here, now it becomes an issue of the method that you want to do. So my advice to you right now is to pause the video, try to solve this problem on your own. So I'm going to assume that you've done that. Now let's actually solve it together. So what we would do is we would say, we're going to use method 1, we're going to say 1 minus 6x over 4x. Remember, division is multiplying by the reciprocal. So we're going to multiply by 2x over 6x minus 1. Now, if you recall from previous lessons, whenever we have values that match but they're in different directions, we can divide them out and simply say it's negative. So this is negative 2x over 4x, and the x's divide out, so this will, and go ahead, 2 over 4 is just 1 over 2, so this will leave you with the answer is negative 1 over 2. And there's your answer. Now, if we want to take the same situation, and this time we want to use method 2, then what we would do is we want to multiply through by the number that's going to get rid of 4x and 2x. This is just 4x, because 4 goes into 2 and x goes into x. So if we multiply top and bottom by 4x, then the numerator, 4x will cancel out, and the denominator will cancel out and leave me with 2. So I'm left with 1 minus 6x in the numerator, and the denominator is 2 times 6x minus 1. Now again, realize the top and the bottom, they do match up except for the fact that their position is switched. So this will divide out and give me negative 1, and hence leave me with negative 1 over 2. Okay. One other point that I should stress is the reason why it's okay to multiply by 4x over 4x is that 4x over 4x is 1. So I'm not changing this expression in any way. Okay. So what you should see is that the first method is straightforward. You just multiply and flip the denominator. The second method requires a little bit more thought up front, but the benefit is that usually the answer comes by a little bit quicker. Again, it's whatever works for you, but go ahead, pause the video now and try this one on your own. And when you try it both ways. I'm going to assume that you've done so, and now we're ready to tackle this problem together. So, just like in the previous problem, the first thing we've got to do is we've got to find that common denominator. So I'm going to first change 4 to 4 over 1. I'm going to multiply top and bottom by x over x. The denominator, I'm going to multiply this by x over x as well, so that I have a common denominator of x squared. So that'll leave me with 4x minus 6 over x all over 2x minus 3 over x squared. So if I want to tackle this using method 1, then I'll rewrite the numerator as 4x minus 6 over x, and I'm going to multiply by the reciprocal, which means I'm going to flip this. So this is x squared over 2x minus 3. Now, we're referring back to previous section here, specifically 5.2, and we want to tackle this. So before we start tackling, we always want to try to factor things out. So we'll notice that 4x minus 6, we can take a factor out of 2, and this would leave me with 2x minus 3. And I'll just tack on the x squared. The denominator is still x times 2x minus 3. We can see clearly that the 2x minus 3's will divide out, and then x goes into x squared, leaving me with x, and the answer is simply 2x. Now, if we want to tackle this with method 2, then we're going to have to multiply through by the value that would get rid of x and x squared. And hopefully that's clear that it would be x squared. Essentially, you would be taking the highest exponent. So when we do this, x goes into x squared, leaving me with x, and x squared goes into x squared, and it would go away. So this would leave me with x times 4x minus 6, x times 4x minus 6, all over, the denominator just left with 2x minus 3. And a similar pattern to the previous way we worked it out is that 4x minus 6, we could factor out a 2, and this would leave me with 2x minus 3. And hence 2x minus 3 and 2x minus 3 would cancel out, and we'd be left with 2x. So, however we look at it, we get the same answer. Alright, and number 4, the spice that we've added to make this seem intimidating is that we wrote it as an exponent of x to the negative 1, x to the negative 2, and down here we've written 3 terms as such. But this, we know that whenever it's negative, it's just 1 over x. It's just a fancy way of saying the reciprocal. So this is just, the numerator is just this. The denominator is just 1 plus 2 over x minus 3 over x squared. And from here, it's, even though the denominator has 3 terms, we're just going to do the same thing that we've always been doing, which is find the common denominator. So the numerator would just be x over x to get x squared. The highest exponent is x squared, so we will want this x over x, and this one would be x squared over x squared. Remember, 1 is the same thing as 1 over 1. And that would create that same denominator, so we'd have x minus 1 over x squared all over x squared plus 2x minus 3 over x squared. And from here, we would just simply tackle this. So using method 1, what we would do is we would rewrite the numerator. We would multiply by the reciprocal of the denominator. And once more, we're back in 5.2. So x squared cancels out. X squared plus 2x minus 3, we can factor this to x plus 3x minus 1. 3 minus 1 because we want a positive 2. And then we can see clearly that the x minus 1 cancels out, and I'm left with 1 over x plus 3. If I instead choose to use method 2, then what I would do is multiply by x squared over x squared, because clearly that would cancel out the x squareds, and leave me with x minus 1 over x squared plus 2x minus 3. And then we can see a similar pattern, which is that we would factor the denominators to x plus 3, x minus 1. The x minus 1s would still cancel out, and I'm left with 1 over x plus 3. So whether, again, you use method 1 or method 2, we see the result is the same. Alright, so this is going to require you to remember the difference of squares, but pause the video now and see if you can solve this one. Of course, using both methods. Going to assume you've done that, and let's tackle it together. So the key here is to realize that the denominators do not match on the numerator. So we're going to have to make them match. So essentially I'm multiplying by the other denominator. Now, one thing I want you to notice here is that w minus 3w plus 3 is w squared minus 9, right? It is the difference of squares, and at this point you should be aware every time you see the difference of squares what is transpiring. 1, I'm going to multiply by w squared minus 9 over w squared minus 9, so that the denominator has the same denominator. So this leaves me with w plus 3 minus, now notice this right here is minus, this is a quantity, so minus parentheses w plus 3 all over, well, all this is over, I want to write it as w squared minus 9. And when we divide the bottom, we're going to have w squared minus 9 plus 9 over w squared minus 9. Now this is nice because w squared minus 9 is going to cancel out because they match up. The numerator here is going to become w plus 3. If I distribute the negative, I'm going to get negative w minus 3. And the denominator is just going to leave me with w squared. So here this is interesting because these will subtract out, as will these. So I have 0 over w squared, which is just 0. So interestingly, on this problem, there is no need to go beyond this. Things will just cancel out. Now, there is, with the canceling of this, is whenever they're positioned, the denominators match up, or even if the numerators match up, they will divide out. We could show via the reciprocal, so we could have said w squared minus 9 over w squared minus 9 plus 9 to illustrate that these would divide out. But I think it's easy enough to see that anytime you have a situation where it's a over b all over c over b, when the denominators match, they will divide out. So, hopefully that makes sense. That is actually the end of the section. So, if you have some questions, post them in the comments, send me an email. Outside of that, keep working.